Hello everyone, my name is Neil Jackson and this is Lab 3 entitled Magnetic Field of a Bar Magnet for Physics 2. So the introduction for this lab was quite simple. We were tasked with computing the distance dependence of a magnetic dipole, and we're going to compare this to the known quantities predicted by the Biot-Savart law. In the middle of the slide I have some listed different forms of the Biot-Savart law that we use in the lab to help us calculate this value. And understanding this lab gives us a greater appreciation for the sensitivity of magnets, and with this appreciation we'll be able to invent and engineer new and better technologies for the future. Alright everyone, so you may be wondering, well, how do I measure magnetic fields? Because I can't see them. I can know what they do, I know their effects, but I can't see them, so how do I measure them? So we use the Tesla meter app on the iPhone to measure the strength of the magnetic field. There's actually a little magnometer inside most phones nowadays that help determine the direction and field strength of magnets, which is extraordinarily useful. And down at the bottom of the slide, I've listed that depending on the orientation of our bar magnet, that changed whether the X component increased or decreased. And we also had to make sure that the phone was in line with Earth's magnetic field in order to cancel out the effects from the North and South Pole. So we were just measuring the magnet itself. So after running the experiment and recording all the data in the Excel sheet provided to us, we get the following results. So as we can see that as we bring the magnet closer to the magnometer, the magnetic field gets larger. This is fairly obvious and fits with our intuition. The closer you are to the source, the stronger the effects are. However, our data was plotted in a logarithmic scale. This is very, very special. First off, we can immediately tell that the slope of the graph, thereby our end value, is negative 2.916. Because we're in a logarithmic scale, if we were to switch this back to a normally linearly increasing scale, we would see that this linear line would transform into a exponentially decreasing function. This points to the fact that the Biot-Savart law is truly an inverse cube law at distances very far away from the magnet. In order to calculate the magnetic dipole moment, we worked backwards from the Biot-Savart law and the y-intercept and the other formulas given to us in the lab document to get that mu mag is equal to k over 2 times magnetic constant, which came out to be roughly 1.89 amps meters squared. Now that all the experimentation was done, we could put everything into our GlowScript code, which I have done here, and in the upper left-hand corner you'll see a section of the code describing the function that generates, or that tells us what our true magnetic field vector is. In the lower left-hand corner we have the code that allows us to visualize and see the magnetic field at a 45-degree angle from the magnometer, and then finally we have off to the right the part of code that tells us where all the vectors of the magnetic field are. And here is a run of my GlowScript. So, as you can see, I have labeled all my arrows and everything, and then we have a great view of my magnet in the center, as well as the 4 perpendicular axis magnetic field vectors, the 2 orange inline ones, and then this big magenta one up here, which represents the off-axis by 45 degrees magnetic field vector. To answer the what if and why questions, if I had not orientated my phone correctly, my results would 100% be off. My X components and my Y components would be interfered with by the Earth, and I would be getting the wrong results. I should be able to correct this though if I were to multiply my then magnetic field times the tangent of the angle theta. And for the Y question, if I had 2 magnetic dipoles and they were right up against each other, I just expect my results to gain in size. It's the same thing as having 2 electric dipoles pretty close together. All we're doing is adding together the 2 magnetic fields through superposition in order to get a larger value. And for my results and possible errors, I got that my end value would be negative 2.9, which is approximately 3, which is the true theoretical value, that's good stuff. I got that mu mag is approximately 1.89 amps meters squared, and then the off-axis magnitude of the magnetic field was 0.466, whereas the computational model 45 degrees off-axis magnetic field was 0.0043. and the possible errors in the lab that could have contributed to this difference of values could be human error and not properly ensuring the phone was always in line with the Earth's field. And another source of this could just come from the fact that we live in a very technologically advanced world, and it's kind of impossible for us to remove every single form of the magnetic field from everything around us. Thank you very much for watching. Have a great day.